So continuing on with lesson 11.6, here we're going to find the volume of a similar solid. So we did a little bit with this in the last lesson. We want to remember that whenever we're talking about similar figures, we can talk about scale factor. So if I'm going, now they don't tell us which pyramid was first or second, but it's all proportional, so it's okay. If I'm going from pyramid A to pyramid B, that makes this my original, and that makes this the new one. Or pre-image and image, if you want to think of that in more mathematical terms. Okay, so I'll write that in as well. Pre-image and image. And we learned back in our transformations chapter 4, that our image is our new one where we go to. Okay, all right, now if we had gone the other direction, it's okay, the proportion will be the same, but let's see what it is that we're looking at. We see that the ratio, my K value, my scale factor here, is always going to be image over pre-image. Or you can think of it as new over old, new over original, something like that. So my image has a height of 6 meters. My pre-image has a height of 8 meters. So it's going to simplify down to 3/4. So my scale factor here, going from pyramid A to pyramid B, is going to be 3/4. Now where that comes into play is what we saw in the last lesson, where they say the volume of our new one, which is pyramid B, over the volume of our original one, which is pyramid A, is going to be equivalent to the scale factor, K, cubed, because we're talking about volume, that's why they cube it. Okay, so I'm going to fill in what we know. So do I know the volume of pyramid B? No, I don't, and that's what they're asking us to say. They say find the volume of pyramid B. So I'm going to put an X here. Do I know the volume of pyramid A? Yes, it's 96 cubic meters. Do I know my scale factor? I do, it's 3/4. And I'm going to cube that. Let's make that look like a 4, not a 9. Okay, all right, so just to keep it straight, it's always image over pre-image. So that's how we got our scale factor. And even when we do our volume, image, pyramid B, over pre-image, pyramid A. Okay, so they have the same ratio. All right, so now I can go ahead, just do a little bit of math here. X over 96 equals, I'm going to cube that, so I'm going to get 27 over 64. If I do a little bit of cross multiplying, 27 times 96, it's going to give me 2592. 2,592 equals 64x. I'm going to divide both sides by 64, and I don't have enough room to show that, but yeah, that's what I'm going to do on both sides. And when I divide by 64, I get 40.5. So, oopsies, 40.5. There we go. And I'm going to label this, this is my volume, so meters cubed. So the volume, that looks like a 9, but this is a 40.5 cubic meters is the volume of pyramid B. Now, if I think about it, does that make sense that I would say that this is 40.5 cubic meters? And it does. I can see that my volume was 96, so it makes sense that it's smaller. And if I look at everything, that seems proportional, because it is. Okay, let's try another one just to practice that a little bit more solidly. So pyramid C and pyramid D are similar. They have to tell us that. Find the volume of pyramid D. Okay. So again, I'm going to go from C to D. And again, if you're wondering if I went from D to C, would that work? And it would. If I did it this way, my scale factor would be different, and then the way I would set up my proportion would be different. It would all work, okay? I'm not going to do that just so I don't confuse people, but if you want to give it a try on your own, you're obviously most welcome to. All right, so I'm going to first go ahead and set this up. Volume of pyramid D over the volume of pyramid C. Okay, so this again is my original. This is my new. So in other words, pre-image over image, which is why when I wrote this, I put the image on top, the pre-image on the bottom, or the new on top, the original on the bottom. All right, now I'm going to set that equal to my scale factor cubed, right? So my scale factor is going to follow the same pattern. It's going to be the image 3 over the pre-image 9. Okay, or the new over the original. All right, so let's see. The only other thing I can really substitute in here is that I did not yet replace the volume of pyramid C with 324 cubic meters. So I'm going to say volume of pyramid D over 324 cubic meters is going to equal, and I can simplify this to 1/3 cubed. Okay, all right, I can replace volume of pyramid D with x over 324 equals 1 over 27. Cross multiplying, I get 27x equals 324. Divide both sides by 27. And whenever I do that, I get an answer of 12 cubic meters. If I look back at my answer to say that the volume of pyramid D is 12 cubic meters, and I see what the volume of pyramid C was, it all looks good. Okay? All right. And when I say good, I just mean it's not like I got an answer that was bigger. So at least I know it went in the right direction. And that's comforting just in that. So that would be my answer. All right, let's turn the page. We have a tiny bit more. We're just going to take a look at composites. So a composite, again, is whenever you take two solids and put them together. And we're going to find the volume of these two composites, and then that will wrap up this lesson. So the volume of this composite solid, we're going to find the volume of the pyramid that's on top. Okay, and we're going to add it to the volume of the cube that's on the bottom. Now the cube is going to be really easy. That's going to be length times width times height. The pyramid isn't bad either. It's the 1/3 the area of the base times the height, and that's of the pyramid. This is of the cube. So that one's going to be a little bit more involved, but still very doable because our base is a square. So the base up here is going to be a square as well. So that makes that really nice to work with. All right, so let's substitute things in. 1/3. Now the area of this base, and this is what I'm talking about right there. The area of that base is going to be 36. And then the height of that pyramid is 6. Okay, so I've substituted all that in. Now I'm going to add to that the length, width, and height, the volume of this cube. So the length, they all happen to be, so this is going to be 6 cubed, which I'm just going to actually, well, I'll write it like this so you can see where it comes from. Okay. All right, now I'm going to do a little bit of simplifying here. I can take 1/3 of 6 and say that that's just 2. 2 times 36 is 72, and I'm going to add to that 216. So whenever I add 216 plus 72, my answer is 288. Label this meters cubed, and I'm good to go. Okay, that one wasn't bad. All right, let's try one more to finish it up. And let's see what they're giving us in this problem. So here we have similar scenario, except that our base is not a square, it's a triangle. But that's okay. All right, so let's see what it is that we have. Oops, sorry. There we go. So again, we're going to find the area of the pyramid. Let's redraw that. So when I draw these, just if you're looking to see, I like to draw the base, kind of put a floating dot somewhere up here, and then connect it to each of my vertices. And that gives me a general look of the figure. Okay, now whenever I draw a prism, I like to draw the two parallel bases. So here's one, here's another, and then I just connect the corresponding vertices. Again, it's a little scratchy here, but it kind of gives us the idea. All right, so the formula for volume of a pyramid is 1/3 the area of the base times the height. The formula for volume of a prism is the area of the base times the height. And this time, instead of writing length times width times height, I can't do that like I did in this problem up above because we're not dealing with a cube. That's the nice thing with a cube or a rectangular prism. We're dealing with a triangular prism, so I have to do capital B, okay, the area of that base. Alrighty, so even though I've written it like this, these capital B's are going to represent the same thing because they are congruent. So this base here it's going to have the same area, obviously. So let's find that capital B first. So this here, if I draw everything in, they're giving me that this is a right angle, so I know this is height, and it's marked as 4 feet. The bottom of my prism is 8 feet, or the bottom of that triangular base, rather, is 8 feet. And so now the area of this is going to be 1/2 base times height, which is 1/2 of 8 times 4. So that cancels out. I get 4 times 4 is 16. So the area, my capital B here, is 16 square feet. All right, so now if I substitute that in, this is 1/3 times 16. Now the height, we're talking here in this case about the height of, oops, wrong one, the height of this pyramid. Okay, so that's why it's going to be 3 that I'm going to put in here. All right, now I'm going to add to that, and if it's easier for you to do these two completely separately, by all means do that. Do whatever works for you. I just kind of set it up so you could see what our pieces were that we were subbing together. But at this point here, it can get a little bit muddy if you're doing them all together like this. So if it's confusing, just kind of draw a line there. Do the pyramid one first and the prism second, and then combine them. But we'll continue on. So we found the area of this space here, which was 16. We found the height of that pyramid, which is 3. Now I'm going to go ahead and look at the prism, and I'll even do that in a different color. The area of this space here, it's the same, so this is also 16. And now the area of this height, now we're talking about the height of the prism, is going to be 5. Okay, now if you had them flipped, that would obviously definitely make a big difference. All right, now this 1/3 and 3 are going to cancel completely out, so I just have 16. And then 16 times 5 is going to give me 80. So if I add those two together, I get a total answer of 96, and I'm going to label it cubic feet. So the volume of this composite figure, which is another word for like a combined figure, it's made up of multiple solids, is 96 cubic feet. Great work, guys. Excellent, excellent, excellent.